Welcome to The Explainer. Today, we are unpacking an absolute game changer for developers and data scientists alike. We're looking at the Hugging Face pipeline, which is, quite frankly, the ultimate tool for simplifying AI model implementations. If you've ever felt completely overwhelmed by the sheer complexity of getting an AI model up and running, well, you are definitely in the right place.
But before we get to the magic, let's talk about the elephant in the room. How hard should AI inference actually be? Historically, it's been a massive headache. You can't just grab a model off a shelf and hit go. Developers have had to wrestle with complex underlying code, handle totally different data modalities from scratch, and write tons of custom logic just to get a simple prediction out of a model. It's tedious, it's super error-prone, and it really slows down innovation.
Okay, let's dive into this roadmap. First, we'll look at uncomplicating AI inference, then the pipeline abstraction, modalities and tasks, power parameters, and finally, scaling for production.
All right, Section 1, Uncomplicating AI Inference.
To really appreciate the solution here, we have to acknowledge why manual inference is such a chore. It is incredibly complex. You see, you typically don't just need a model. You have to figure out how to perfectly pre-process your inputs, whether that means wrestling with tokenizers for text or setting up feature extractors for audio and vision. Then, you've got to manage framework-specific weights, figuring out if you're using PyTorch or TensorFlow, and then write custom post-processing code just so the model's output is actually readable. It's a ton of manual plumbing, and frankly, it's prone to springing leaks. Which brings us to Section 2, the pipeline abstraction. And here is where Hugging Face waves its magic wand. The pipeline is basically a black box solution for all those inference headaches we just talked about. Behind one simple command, it automatically wraps up 3 crucial steps. Step 1, it loads a default preprocessing class, like your tokenizer, to encode the input. Step 2, the model actually makes its prediction. And Step 3, it automatically applies post-processing to enhance the output so it actually makes sense to you. All seamless, all right in the background.
And this brilliantly illustrates just how powerful this abstraction really is when you want to upgrade or test new models. Let's say you're doing automatic speech recognition. You might start with an older model like Wave2Vec2. It works, sure, but it totally lacks punctuation and casing. Well, with the pipeline, upgrading to OpenAI's Whisper Large v2, which is trained on 10 times the data and has perfect casing, literally requires changing just one string of text in your code. The pipeline handles all the crazy underlying architecture shifts for you.
There's this fantastic quote right from the documentation that hits the nail on the head. Pipelines are great for experimentation as switching from one model to another is trivial. And it's so true. Because the pipeline takes care of the nasty plumbing, you can spend your time hanging out on the Hugging Face hub, swapping out models, and finding the absolute best accuracy for your specific use case.
Let's move on to Section 3, Modalities and Tasks. We've talked about the abstraction, but just how versatile is this tool? Well, it's basically a Swiss Army knife for developers. We're talking effortless support for natural language processing tasks, things like named entity recognition, sentiment analysis, and summarization. But it doesn't stop at text. It tackles vision tasks like image classification, audio tasks like the speech recognition we just discussed, and it even bridges the gap with multimodal tasks. Best of all, you don't have to learn a brand new framework for each data type. The syntax stays virtually identical.
Let's look at a really cool multimodal example to drive this home. Imagine you've got an image of an invoice. Using the visual question answering, or VQA pipeline, combined with an OCR tool like PyTesseract, you can literally just pass that image into the pipeline and ask a text-based question about it, like, hey, what is the total amount due? And the model extracts the answer straight from the image. It is insanely powerful and takes hardly any code to execute. Next up, Section 4, Power Parameters. Okay, going from basic usage to advanced configurations, one of the absolute coolest features is chunk batching. You know how sometimes you have a massive file, say a super long audio recording, and it's just way too big for a model to swallow whole? Instead of you having to write the tedious logic to chop it up, process it, and glue the text back together, the pipeline does it automatically. It slices the large item into digestible parts, processes them, and hands you back a nice, cohesive output. It is a huge time saver.
And there are a few other specific parameters tailored to make your life easier. By passing device equals n, you can automatically force the pipeline to pin the model to a specific GPU. Doing audio? Passing return timestamps is an absolute lifesaver because it tells you exactly when words were spoken, which is perfect for generating subtitles. And if you're subtitling entire movies or hour-long videos, combining that with the chunk length S parameter lets the model chew through huge files that would normally just crash your system.
Finally, we have Section 5, Scaling for Production.
So how do we take all this out of the sandbox and into a heavy-duty production environment? When you're dealing with massive datasets, how you feed the data is absolutely critical. If you try to pass a giant dataset into memory all at once, you're practically asking for that dreaded CUDA out-of-memory crash. But if you use a dataset iterator by calling .data on your dataset, the pipeline gets smart. It uses data loader under the hood to stream the results sequentially. This feeds your GPU as fast as possible without blowing up your system's memory.
But hey, what if it's not the dataset that's huge, but the model itself? Standard pipelines load models onto a single device. But if a model is just way too big for one GPU, you can simply pass device map equals auto. By hooking into the Hugging Face Accelerate package, this one little parameter automatically figures out how to efficiently chop up and store the model weights across multiple devices. You don't have to manually slice up the model, the pipeline handles the whole orchestration. That means you can easily run massive, state-of-the-art models. Think Facebook's OPT 1.3b, or even the gargantuan Bloom models. And to make scaling even more efficient, if you install the Bits and Bytes library, you can pass the load in 8-bit argument. This drastically shrinks the memory footprint of these behemoths with barely any drop in performance, making production deployment way cheaper and far more accessible.
Wow. Okay, we've covered a ton of ground today, from the basic abstractions all the way to running massive 8-bit models across multiple GPUs. But if you take away just one thing from this explainer, make it this. The Hugging Face pipeline entirely removes the friction of AI implementation. So I'll leave you with this final thought. Now that the complex inference code is no longer a barrier, now that the plumbing is completely handled for you, what are you going to build? Head over to the Hugging Face Hub, find a model, and start experimenting today. Thanks for joining me.